Yeah, hi everyone. I'm very glad to be here because I think this is my very first public sharing outside the booking. And I've just moved from Shanghai last year to Europe. So yeah, nice meeting everyone here. Today I'm going to talk about the rate limiting, the rate limit directive, which works in the federation router layer. I think there's a lot of maybe a lot of companies now already in federation architecture. So I think this talk can have us discuss a little bit more. Here's a plan for today. I will quickly start with the federated GraphQL in booking with some interesting numbers. Then I will explain why rate limiting in federation router layer is needed. And I will dive into the technical detail for their whole rate limit directive design. And if there is time, I can go with a very little demo on the booking.com GraphQL endpoint publicly to a live small details. So Booking adopted the federation architecture for a while. I think it has been 5 or 4 years now. And our team is maintaining the federation router. And our partner is Apollo. Yeah, we have been working with Apollo for years now. And our team maintains the federation router, and it serves as a single endpoint to serve data for not only customer-facing traffic, but also for hotel holder traffic to query the data across multiple product and domains in booking. So, and it's not only the front-end application consume the data through the federation router, it's also for the internal service-to-service scenario. For example, now because the AI stuff become more and more popular, we have multiple AI agents. They also need to consume the data and to build some AI product. So the federation router, the federated traffics also become the main engine for these kind of service-to-service data consumption scenario. This is if from the domain and product perspective. In federated GraphQL, we serve almost all the booking data domains. Almost all the vertical, like accommodation, marketplace to rights or insurance, they all have a backend service we call subgraphs federated by federation router. So if there is a product team, they're trying to build a new product, so there is a high chance that they don't need to create a new backend API. They can directly fetch the data from a federation endpoint. So I think that's this kind of architecture really speed up the product building and new feature going to the market. I think that's why we adopt this architecture. That's the major reason, I think. So in summary, the federated GraphQL in booking now serve the most diverse and the most critical traffic. So that's why the performance and the stability of the whole federation system will directly impact the most booking customer user experience. But before we dive into the rate limit directive design, we can revisit a little bit on the federation architecture. So in federated GraphQL, the clients don't send the request to the backend system directly. It will send the query to the federation router, and the federation router will analyze the incoming request, break it down to sub-requests, then intelligently dispatch these sub-requests to the backend system, and then aggregate the response back to the clients, the data consumers. So this These architecture can decouple the data consumer and the data provider back in the backend. So it's highly, accelerated data consuming speed. But it also made us facing a unique challenge, which is because one GraphQL query after query planning happening in federation router, it will become multiple sub-requests, sub-query going to this backend system, which is subgraph services. So that means if there is traffic spike happen from the outside of the federated system, this subgraph services might be overloaded by the traffic spike. So that's why we need a rate limiting and throttling mechanism in the router layer. We had multiple very terrible outage happen last year. Because there is some bot traffic, and we cannot prevent the bot traffic because some bot traffic is a good bot traffic because the search engine or some other websites, they need to get the data from booking and for the ranking from the search. So not all the bot traffic are bad traffic. So that means even we have the traffic gateway to do the traffic control before router layer, it can ensure the incoming traffic stay in a safe number because there is also rate limiting in a different layer, right? And for the traffic gateway, they will control the traffic coming from the internal system always in a safe number. But for federation architecture, even that number is safe, it can become a huge volume of traffic goes into the subgraph system. That's why the rate limiting is also a must-have feature in federation router. The last year we have a terrible outage, which is there are some traffic spike caused by the bot traffic. And this bot traffic requires a huge amount of data from the GraphQL endpoint, a federated GraphQL endpoint. And there is critical backend services cannot handle such high traffic spike. And what made the things worse is one subgraph request. This subgraph need to fetch multiple data from the dependent system. And these different are quite important. For example, is pricing, is reservation. So the multiple critical system was overloaded in the same time. So it's caused a lot of booking loss and a lot of engineering working out to mitigate the whole issue. So yeah, so that's why we need to think about how we do the rate limit in the federation router layer, because it's not only about the SLO violation, not only about the security, it's about the business loss. So, and months ago we deliver the rate limit directive, which is a booking infra native. I'm saying it's booking infra native is because we not reinvent the rate limiting infra for this directive. In booking, we have the infra team, they already have the rate limiting infra, and they can provide an API for every backend service to do the rate limiting checking. And they have a very friendly protocol between for these backend service to use. So we reuse the rate limiting infra for this directive. As a GraphQL platform team, what we are focused on is how to deliver this functionality to be a GraphQL friendly in a GraphQL friendly way. So this is the whole design. So we delivered a rate limit directive, and a subgraph schema owner can just put rate limit directive to the field they want to have the traffic control. And this directive accepts very simple options. You can have the configuration with the options. For example, you can put the max request number and the TTL, how is the time window for this max request number, and you can have the condition. Condition is for the schema owner to define the differentiate the traffic group. So for example, if they want to have 100 requests per minute per unique user ID, then they can simply put these to this endpoint. And also we support the schema level rate limit. That means they can have a global rate limit on the whole subgraph services. So for this part, it's just for the schema owner to easily put this directive to the schema element they want to protect. And after this subgraph published to be part of the supergraph, the federation router will, because the supergraph will be updated into the federated router services, and we have a plugin, rate limit plugin. It will pass this directive and translate it to a the rate limit infra native format. And for each incoming request, we will check if this request should be rejected or allowed by checking the rate limit infra. So the workflow is quite simple. Yeah. So for now, we support two levels, like I mentioned, two levels of rate limiting, the schema level and the root field level. Yes, the subgraph owner can apply different level to have different traffic control strategy. Yeah, so the applying flow is like this. For each incoming query, it will check if this root field has the root field level directive applied. If there is root field directive, rate limit directive applied, it will evaluate the rate limiting and throttling with the rate limiting info, and to decide if this request should be dispatched to the subgraph or not. Same as the schema level. If there's no root field level directive for that request, it will try to see if there is schema level rate limiting, and to the same thing to allow or reject a request. Yeah, that's yeah, basically that's it. I think we still have time. I can. Okay. Oh, I have no network connect. Yeah, it's because I need to connect to the network, but I'm not sure how's the Wi-Fi. Yeah. Do we? I can connect to my phone. That would be quick. Yes, I can.
I think we have the Wi-Fi password.
Oh, it's okay. It just use the no. It just use my phone. It's no.
Sure?
Yeah.
Otherwise, this is it.
Oh, I can use this. It's quick. So. What? Oh, that was a typo. Yeah, yeah. This is public endpoint, so I think it's Yep. In booking, we have a unified endpoint to access the GraphQL. and we can do I already have a demo subgraph which is also in production, but let's see, yeah, it serves very simple hello world query, query, and we can do it quickly. And I put the maximum request is 2 in 1 minute. It's so. Yeah, it's a very. Yeah, it's a very simple. Yeah, you can see because there's so many requests sent into that endpoint, so it's a get 429. Yeah, that's that's a little play around with the read limit directive. It's yeah. Thank you. Any questions?
So this plugin, is it open source or something private booking?
Yeah, it's private in booking because we are using the booking infra stuff. But yeah, but I think the mechanism is kind of same. We pass the subgraph, and we get the configuration from the directive, and we check the limiting or not with a with an API. So simply we can use Redis or some other storage in the router layer to do the similar thing. Yeah.
Okay.
Yeah.
If you actually hit the rate limit,
Yeah.
what do you get in the response?
You will get too many requests, and with I mean, it still can be partial response.
So it's just part of the error.
Yeah, it's part of the error. Yeah.
Maybe can you show again?
Yeah, sure.
I think it was visible there.
One. Okay. Sorry. Yeah, like this. Let me. Okay. We can remove these. Yeah, it will be the part of the errors.
Is the HTTP code 429 as well, or is it 200?
I think it's 200. Yeah. Oh, sorry. Yeah, it's 200 actually.
It's minus B?
Yeah.
Yeah. Not 200.
Yeah, 200.
Is that a specific reason you didn't choose HTTP, a different HTTP code for that? Like,
You mean why is 200 is not 429? Or
why not using HTTP error codes to represent the rate limits instead of using GraphQL? Like, you're using GraphQL error there, you could also have gone like plain HTTP plus JSON.
I think that actually goes against GraphQL spec, right?
So far.
Current GraphQL spec.
There's a new content type actually called GraphQL response plus JSON.
you mean the content type? I don't get the question first.
Yeah.
This you mean the content type is not a GraphQL thing, or?
Yeah, exactly.
Okay. Yeah. Okay. I think it's because the service I mean, it should be something in the traffic gateway side. I think I will let them know because we return them in correct content type, but they have something, you mean, between our endpoint and the customer, there is something for the whole request and response modification between these. So I will, yes, good point. I will talk with them.
Do you have some kind of observability for the rate limiting behavior?
Yeah, we have an internal dashboard for the, for example, what operation being blocked, what can't be blocked, what's the subgraph is in rate limiting. Yeah, we have all kinds of observabilities. Yes, please.
My question is, if we have one graph, one query,
Yes.
with sub-queries in it,
Mm-hmm.
with different ratings,
Mm-hmm.
one of them could return
Yeah.
the...
4 to 9. Yeah.
Yeah, and the bigger part would still return the data.
Yes, exactly.
Yeah, okay. So probably that's why it will work on the body request. Because if you have a graph, a query that gets a lot of data, and a subgraph of it hits the
Oh,
rate
it's
limit.
partial.
Yes, so it's that part.
Yes, partial response.
The
Yeah.
partial data.
Yeah. Okay.
Out of curiosity, since we're here, the rate limit that you use for this example is a global one or is a field one?
It's field one.
I see. So you can get in theory partial data. You know.
Yeah, but I only query the hello world here, and there's only one data I could request. So it gets relimited, but it's nullable. So, you know. Yeah, I think that's it. Thank you. Thank you, everyone.